So, ARM, the full form of ARM is Advanced Risk Machine Processor. It is a family of CPU based on RISC architecture, that is Reduced Instruction Set Computer. ARM processing is nothing but the advanced version of RISC machine. So there are some enhancement which are made from the RISC processor. RISC is simple but a powerful instruction that execute within a single cycle at a high clock speed. So ARM processor uses the RISC architecture. Now the application. ARM processor is mainly used for commercial purposes, like it is used widely used in smartphones and tablets and digital cameras, medical devices, robots, wireless communication, printers, home appliances, and it is widely used in sensors and Internet of Things devices. Now the features. The feature which makes the ARM processor better than the other types of processor are its architectural simplicity, and it because of which it allows a very small implementation, and it also allows very low power consumption. And when we come to the history, so it is developed by the Akron Computer Limited at the year 1985. So it was firstly named as Akron Risk Machine because Akron was a company which developed the ARC processor, but later it is changed as Advanced Risk Machine. Now the ARM architecture. So before going to the ARM architecture, we will discuss about the RISC architecture, which consists of large uniform register files, load and store architecture, simple addressing mode, and uniform and fixed length instruction fields are present. Now the enhancement which are made in the ARM processor is each instruction controls the ALU and the shifter, and it also have a auto increment and auto decrement addressing modes, whereas in RISC machine only simple addressing modes are present. Next is multiple load and store architecture. In RISC, single load and store architecture is present, and it is conditional execution. So the advantage we got after the enhancement is high performance, low code size, because of which it can be used in a smaller devices like smartphones, and low power consumption, low silicon area. Next is based on Berkeley RISC machine. ARM architecture is fixed length instruction. It consists of pipeline in concept and load and store architecture. And ARM is a 32-bit architecture. So most of the ARM implement two instruction set, that is 32-bit ARM instruction set and 16-bit thumb instruction set. Next, we will discuss about the architecture of ARM processor. So, ARM architecture consists of ARM register, and it contains the address of the instruction, and next PC, which contains the next address. Register bank, it holds the all the temporary register, and barrel shifter, it do the operations like shifting of bits to right and left, and it also rotates the data. ALU to perform arithmetic and logic operation, buses which to transfer the data, instruction decoder and controller to decode and control the instruction, data out registers and through which data is sent and or get back. Now, about the architecture, address register is 32-bit register. It contains the address of the instruction. Next is register bank. Register bank contains the instructions in, and it is connected to ALU through two data paths, that is A bus and a B bus. Through A bus, it is directly connected to ALU, but through B bus, it is connected to ALU via barrel shifter. So in we all I already said that the
Hello.
barrel shifter
Hey,
is used
meeting
to
in the left
perform the
area.
operations like uh, shifting of bits to
Hmm.
left and right, or even rotate the data.
ಅಂದ್ರೆ
And then
ಮಾಡ್ತೀನಿ
after doing the operation, the
ಸರಿ
result
ಬಿಡು
is sent to
ಬಂದಿದೆ
ALU.
ಬಟ್ ನಂಗೆ ಇದ್ರಲ್ಲಿ ನೀಟಾಗಿ
And in
ಬರುತ್ತೆ
ALU, the
ಶೆಟ್ ನಾನು
operations
ಮಾತಾಡಕ್ ಕೇಳಿ
required
ಬರ್ತೀನಿ
operation is done like addition, subtraction, and other arithmetic and logical operation. And the result is sent to the register bank. In register bank, the result is sent through through a data out register from a B bus, and then the result we will get the result. So both barrel shifter and a ALU act as a combinational circuit, because of which it required only one clock cycle to perform the operation, and it also decreases the time consumed. And a arm is also called as a load and store architecture, because all the operation requires the storing of data which is done in the registers. This is all about the arm architecture. There are many advantages like in arm architecture, like it's low power consumption, it's small size, which makes it better than other processors like itel, etc. And this is all about the arm processor. Thank you.
See, today my topic is features of a ARM processor. Before that, we have to know about ARM processor. This is the introduction about ARM processor.
ಹಲೋ ನಾಗಮಣಿ.
Ah,
ಇವಾಗ ಸ್ಟಾರ್ಟ್ ಮಾಡು, ಸ್ವಲ್ಪ ನಂದು ಆಡಿಯೋ ಬಂದಿದೆ ಅದು ಸ್ಟಾರ್ಟಿಂಗ್ ಅದಕ್ಕೇನೆ.
start ಅಂತ ಹೇಳು.
ಹಾ, ಸ್ಟಾರ್ಟ್ ಮಾಡು.
Hello everyone, I am Nagmani from 4th semester. My topic is features of a ARM processor. Before knowing features, we have to know about ARM processor. This is the introduction about ARM processor. ARM processor is a family of a CPU. CPU is mainly based on a RISC architecture and a CISC architecture. The full form of a RISC architecture is Reduced Instruction Set Computer, CISC, Complex Instruction Set Computer. In a RISC architecture, number of instructions are less and they are very simple. In CISC architecture, number of instructions are more and they are complex. This ARM processor is developed by a ARM company from Cambridge. This develops the 32 and 64 multi-core processor. The RISC processor are smaller computer instruction and they provide a high speed. Due to this, they perform a millions of instructions per second. This is called as MIPS. The features of a ARM processor. The multiprocessing systems. The first feature is multiprocessing systems, which means ARM processor are made to be used in a situation where more than one processor is used to process the data in multipurposing systems. The first AMP processor, known as ARM V6K, had the hardware ability to support 4 CPUs. The next one is second one, memory management. Memory management is a feature of a ARM processor. Memory management unit and memory protection unit are included in this. This management system become a crucial for effectively managing memory. The third feature is memory that is tightly coupled, which means ARM processor memory is tightly coupled. This response is very quick because of its low latency, and it is also used in when a cache memory behaves erratically. The fourth feature is thumb-to technology. Means thumb-to technology was used in a creative variable length instruction sets was the first introduced in 2003. It upgrades the original thumb technology from 16-bit instruction to the 32-bit instructions. Compared to thumb technology, which was previously used, it performs a better. Fifth feature is a large number of a register. Means the ARM processor uses a large number of register to limit the memory interactions, and register include address and the data modes. These serve as the operating system's local memory repositories. Sixth one is pipelining. We all know about the pipelining. It means pipelines are used to process the instruction in a parallel. One pipeline stage involves the breakdown decoding of instructions. The pipeline advances the one step at a time in order to increase throughput. Seventh feature is one cycle execution time. Each instruction on the CPU is optimized from the ARM processor. One cycle execution time. Each instruction has a set length, allowing time for a retrieval of a subsequent instruction before the current instruction is carried out. The clock per instruction of a ARM in one cycle. This is all about a feature of a ARM processor. We have to know why it is so important, where it is used. The application of ARM processor is it is used in a smartphones, tablet, multimedia players. Due to the risk RISC, they are having a smaller instruction set. Due to the small instruction set, less number of transistors. So size of a IC is very small. ARM processor is very small in size, reduced complexity and also less power consumption. These features mainly suitable for the miniature devices. So we use it in today's generations. Thank you.
Hello everyone, my name is Nandita and now I'm going to present on embedded systems. Embedded system is a microprocessor based system that does not look like a computer. 80% of the embedded system's actions are based on a microprocessors. What are embedded systems? An embedded system is an electromechanical system designed to perform a specific function. It is a combination of hardware and software. It consists of three components, mainly hardware component, software component and mechanical component. It is supposed to do only one specific task. This is the picture of a general embedded system. What are the elements of embedded systems? An embedded system is a combination of three things: hardware, software, and mechanical components. And it is supposed to do one specific task only. A typical embedded system contains a single chip controller which acts as the master brain of the system. Embedded systems are basically designed to regulate a physical variable such as microwave oven or to manipulate the state of some devices by sending some signals to the actuators or devices connected to the output port system, such as temperature in air conditioner. In response to the input signal provided by the end users or sensors which are connected to the input ports. Hence, the embedded systems can be viewed as a reactive system. This is the picture of an embedded system. It contains six parts. Mainly, the main part of an embedded system is a system core, which is also a microprocessor or a controller like FPGA or ASIC or DSP or SoC. We will come to know about these in the further slides. Now, for the memory, we use embedded firmware, and for the communication interface, we use USB drives or 9-pin cables. For the output ports, we have actuators, and the other supporting integrated circuits and systems are interconnected to a system core. For the input ports, we have sensors. And for example, in an air conditioner, the sensors sense the temperature of the surrounding and they compress or stimulate the ACs. Moving to the next slide, we have the core of an embedded system. The core of the embedded system falls into any one of the following categories: the general purpose and domain specific processors, microprocessors, microcontrollers, digital signal processors, programmable logic devices, application specific integrated circuits, commercial off the shelf components. So these are the core of an embedded system. Mainly, an embedded system is a combination of microprocessor and a microcontroller. It is very different from a general purpose computing system. know what is an embedded system with the help of an example. Here, for example 1, we have a washing machine. A washing machine from an embedded system's point of view has a hardware which contains buttons, displays and buzzer or an electronic circuitry. And for software, it has a chip on the circuit that holds the software which drives the controls and monitors various operations possible. For the mechanical components, the internals of a washing machine which actually wash the clothes and the input and the output of the water. To know more about the embedded system, let's take another example of an air conditioner. An air conditioner, from an embedded system's point of view, has a hardware, software, and a mechanical components. So, what are the hardware components that are present in an air conditioner? Remote, display and buzzer, infrared sensors, or electronic circuitry. For the software, it has a chip on the circuit that holds the software which drives control and monitors the various operations possible. The software monitors the external temperature through the sensors and then releases the coolant or suppresses it. For the mechanical components, the internals of an air conditioner, the motor, the outlet, etc. For the let's know the difference between the general purpose computing system and the embedded system. So based on the criteria, we have differentiated general purpose computing system to the embedded system. On the criteria of the contents, the system which is a combination of generic hardware and general purpose operating system for executing a variety of applications. A system which is a combination of specific purpose hardware and embedded OS for executing a variety of applications is called an embedded system. Based on the operating system criteria, the general purpose computing system contains a general purpose operating system or simply GPOS. For an embedded system, it may or may not contain an operating system for functioning. For the power consumption, the general purpose computing system consumes more power compared to embedded system. But according to the criteria of the power consumption, embedded system always consumes less power. According to the response time, here the general purpose computing system is not critical, whereas the embedded system is critical for some appliances. Criteria of execution, the general purpose computing system need not to be deterministic, whereas the embedded system is to be deterministic for certain types of ES like hard real-time systems. On the criteria of key factor, we have the performance of the general purpose computing system is the key deciding factor in the selection of the system. The faster is the better. Whereas an embedded system application specific requirements are the key deciding factors like performance, power requirements or memory usage. This is the basic difference between a general purpose computing system and an embedded system. So, this is the differences between a general purpose computing system and an embedded system. Moving to the next slide, we have the classification of embedded systems. Basically, the embedded system is divided or classified based on these four criteria. That is, on generation, on complexity and performance, on deterministic behavior, and on triggering. So, the embedded systems that we see today are the classifications that are based on generation. So, detailing on generation, we have the first generation or 1G. They are built around an 8-bit microprocessor and a microcontroller. They are simple in hardware circuit and firmware developed. The examples are digital telephone keypads. The second generation or 2G. They are built around 16-bit microprocessor and a 8-bit microcontroller. They are more complex and powerful than 1G microprocessor and a microcontroller. Examples for second generation is SCADA systems. For the third generation, they are built around a 32-bit microprocessor and a 16-bit microcontroller. The concepts like digital signal processors, application-specific integrated circuits are evolved. The examples for third generation is robotics or media, etc. The fourth generation is what the embedded systems that we use today. They are built around a 64-bit microprocessor and a 32-bit microcontroller. The concept of system on chips or SoC, multi-core processors evolved. Highly complex and very powerful. The examples are smartphones, fitness bands, etc. Now, let us know the application of embedded systems. The embedded systems are used in consumer electronics like cameras, fitness bands, etc. They are also used in home appliances like in washing machine, air conditioner, nowadays in rice cooker and electric stoves. They are used in security systems like fire alarms and also in the home heating system. They are used in automotive industry, also in telecom industry, and in computer peripherals, and mainly in computer networking systems to connect to connect the data connections between the smartphones, and also they are used in the optic fiber materials. Finally and mainly in the healthcare, as they are used to check the pulse rate, heart rate, or ECG of a patient. This is all about the embedded systems. Here we have come to know about what are embedded systems and what are the elements of the embedded systems, the core which is based on the embedded systems, and also the classifications of embedded system, the difference that we know about between a general purpose computing system and an embedded system, and finally the application. So this is all about the embedded systems. Thank you.
Hello everyone, my name is Nagadeepa. Today I'll be presenting you on the topic real-time operating system. This is the content page of my PowerPoint presentation. It contains what is real-time operating system, what is real-time kernel functions, types of real-time operating systems. So let's look into the topic what is real-time operating system. Real time implies deterministic in timing behavior. RTOS services consumes only known and expected amount of time regardless the number of services. RTOS implements policies and rules concerning time critical allocation of a system's resources. RTOS decides which applications should run in which order and how much time needs to be allocated for each application. So these are the examples of operating system. They are Windows Embedded Compact, QNX, VxWorks, Micro C or OS2, etc. So real-time kernel. What is real-time kernel? The kernel of a real-time operating system is referred as real-time kernel. The real-time kernel is highly specialized and it contains only the minimal set of services required for running the user task. These are the functions of real-time kernel: task management, task scheduling, task synchronization, exception handling, memory management, interrupt handling, and time management. So let's look deep into these functions. Task management deals with the setting up the memory space for the task, loading the task's code into the memory space, allocating system resources, and setting up a task control block, that is TCB, for the task and task termination. What is task scheduling? Deals with the sharing the CPU among the various tasks. A kernel application called scheduler handles the task scheduling. Scheduler is an algorithm implementation which performs the efficient and optimal scheduling of tasks to provide a deterministic behavior. Time synchronization deals with synchronizing the concurrent access of a resource which is shared across multiple tasks and the communication between various tasks. What is exception handling? Deals with the registering and handling the errors occur during the execution of task. Memory management. The memory management function of RTOS kernel is slightly different compared to the general purpose operating system. In general purpose operating system, the memory allocation time increases depending on the size of the block of the memory need to be allocated and state of the allocated associated memory block. RTOS achieves predictable timing and deterministic behavior by compromising the effectiveness of memory allocation. What is interrupt handling? Deals with the handling of various interrupts. Interrupts inform the processor that an external device or an associated task requires immediate attention of CPU. What is time management? Accurate time management is essential for providing precise time reference for all applications. The time reference to kernel is provided by a high resolution real time clock, that is, hardware chip or hardware timer. There are two types of real-time operating system. They are hard real-time operating system and soft real-time operating system. Hard real-time operating system. A real-time operating system which strictly adheres to the timing constraints for a task is referred as real-time systems. A hard real-time system must meet the deadlines for a task without any slippage. Missing any deadline may produce catastrophic result for hard real-time systems, including permanent data loss and irrecoverable damages to the systems or users. Hard real-time operating systems emphasize on a principle a late answer is a wrong answer. For example, airbag control systems and anti-lock brake systems of vehicles are typical examples of hard real-time systems. Next is soft real-time operating system. The real-time operating systems that does not guarantee meeting deadlines but offer the best effort to meet the deadline are referred as soft real-time systems. Missing the deadlines for a task are acceptable if the frequency of the deadline missing is within the compliance limit of the quality of service, that is QoS. Soft real-time system emphasize on the principle late answers are acceptable answers, but it could have done bit faster. Automatic teller machine, that is ATM, is a typical example of soft real-time operating system. If the ATM takes a few seconds more than the ideal operation time, nothing fatal happens. Thank you for this opportunity, and that's all about my topic. Thank you. ಗೈಸ್ ರೆಕಾರ್ಡಿಂಗ್ ಸ್ಟಾಪ್ ಮಾಡಿದ್ದೀನಿ. ಕೇಳಿಸ್ತಿದ್ಯಾ?
ಹಾ, ಕೇಳಿಸ್ತಿದೆ. ರೆಕಾರ್ಡಿಂಗ್ ಸ್ಟಾಪ್ ಮಾಡ್ದ್ಯಾ ಇವಾಗ?
ಹಾ, ಸ್ಟಾಪ್ ಮಾಡಿದ್ದೀನಿ.